Okay. So now we're gonna do Dijkstra Algorithm. So first, let us understand what exactly is Dijkstra Algorithm. Dijkstra Algorithm says that if you have on for suppose say says first suppose we have a node B having an incoming edge from you, um, then distance of u plus cost of edge between u and v. If it's less than distance of v, this distance of v can be, the distance which is occurred from the other part to that particular node. For example, there is an outgoing edge of, for suppose there's an one more incoming edge from v. So distance via v can be this. Like not just v, but any other node. From any other node, the distance of v which is pre-computed, if it's greater than the distance we are getting via path u, then we are gonna update the distance of v as distance of u plus cost of edge between u and v. So for this, we are gonna use priority queue. Basically, Manjeet, right? So now, what am I saying is that for Dijkstra, we need to remember that the edge dates or cost is always greater than equal to zero. That is, they are always positive. Dijkstra fails when we have negative edges, right? So let us see how it's we're gonna work it out. Mm, okay, let us take this example. We are given with adjacent adjacency list. 2 comma 6, 2 comma 3, 0 comma 1, with cost 6. Now 1 has an edge to 2 with cost 3, and 1 has an edge to 0 with cost 1. Okay. They gave this is an undirected graph, so we don't need to draw the arrows. We can just keep it as okay, 1 and 2. We got this as 6, 2 to 0, 2 to 0. 2 to 1 is 3. Sorry. 2 to 0 is 6. 2 to 1 is 3. 0 to 1 is 1. Okay. So this is our graph. And now we need to find the distance. So for this, let us take a priority queue. Having distance and right. Now they gave the source is 2. So we are gonna insert before that let us declare the distance matrix. Distance matrix for the three of them would be 0, 2, 3. Infinity, 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 infinity. And why are we having it as infinity? We are having it as infinity because we are initializing them as infinity as we don't know the distance and we assume them as maximum distance. Okay. So now we're gonna insert node 2 distance here. Okay. So from 0, we have distance of, as it is a source index, we don't have a parent node. So it's gonna be 0 plus 0, the edge first, which is less than infinite. So we're gonna update this to 0 and we're gonna pop this out. Now what we're gonna do is we're gonna push its neighboring nodes. Right. The neighboring nodes is gonna be 1 and 2. So 1 comma 1, that's gonna be 1 plus 0, that is less than infinity. So we're gonna update it to 1 and we're gonna pop this out. And then we're gonna push the next node, that is wait. We would have already pushed this node, and when we are popping this node out, we're gonna push. So on, it's gonna be mm, three comma two. Once we have these both, once you have these both, the priority queue is gonna reset this, and the front of the queue is gonna be 3 comma 2 and 6 comma 2. Right. So now what we're gonna do is 3 plus 1, which is 4, is less than infinity. So we're gonna update 2 to 4. Oh, 4. So this is what we are supposed to get. Here, if we take this up, what we're gonna get is 6 plus 3, which is gonna be 9, which is greater than 4. So it's not gonna get updated. So yeah, this is how priority queue works. What it's gonna do is every time we get the smallest distance, it's gonna be taken to the front of the queue. So to code, let's code this up. So what we're gonna do is we're gonna create vector distance of size nodes, and we're gonna initialize it with infinite, which is nothing but our int max. Okay. Now what we're gonna do is we're gonna initialize queue, priority queue, essentially. Where, where pixel, right? Now, for source node, we are gonna change distance to 0, and we are gonna push 0 comma src into the queue, the priority queue. And priority queue is not empty, current node is pp.run dot second. Well, distance is gonna be pp.run first. If current distance current node, then we're gonna continue. Graph rated G of current node if next node is gonna be ip dot first edge gonna be ip dot that is the cost is gonna be ip dot second. If distance of current node plus the cost is gonna be less than distance of next node, then we're gonna update distance of next node split. We're gonna push distance of next node and next node. So we are done with the Dijkstra algorithm, but here they said that I think if we can't reach the nodes, okay, a worst case scenario, if we can't reach a node, then replace INF with -1. So for when I is equal to 0, I is less than origin dot size or from distance dot size I plus plus if bi is distance of I is equal to INF return distance. So for I'm so habituated to the queue that I'm using front while it's supposed to be top. I'm sorry. Optimizing our okay. I forgot to pop it out. Mm. That here is so bad. Yeah, so that this is the code first we are initializing distance vector to infinite and then we are updating the priority queues and then we are changing INFs to -1 if the nodes can't be reached.